Alright, so now continuing with the next reaction. Let's assume that this is our starting material, right? And it's actually occurring in the presence of a dehydrating agent like our H2SO4. So you are going to have your lone pairs on this particular oxygen attacking this hydrogen, and you are going to have a lot of HSO4 minus in the solution. Right, so from here I'm going to move straight into the formation of the carbocation, because you know what is going to happen. This will form a water and it will leave, and now you are going to generate your carbocation. So I'm just skipping this particular step and create my carbocation straightforward. So I'm still going to have right, and on this side I'm having my CH3. Usually they don't put the CH3 there, you just do the dash formula, right? They are all same. So CH3. Now I'm going to generate my carbocation. This one, my carbocation will be a positive charge. So with this, ask yourself, because here you are going to talk about coplanarity. This methylene group, and methyl group, each of them can move. This group cannot actually move because it is not coplanar. That one you can actually see it clearly that it's not coplanar. The CH32 is also pointing away, so it looks like it is not also in the same plane as this p orbital. But if you look at this particular side, which is this particular bond from this carbon all the way to this carbon, this bond is actually planar, or it's in the same plane with this p orbital. For that matter, it can migrate, and when it migrates, that's when you're going to have it's moving into the p orbital, as you can see. And then let's see what we are going to have next. So now you're going to see that the bond has been broken, all right, and now the linkage is directly from this carbon all the way to this carbon. So I can do something like this, right? Do something like this. Okay, and now you see the bond is between this carbon and this carbon. So now I'm going to draw it straight, just a straight line from this side. And where I actually broke the bond, we'll have this particular carbocation. So now let's see the structure I'm going to have. This carbon is the one that's having the carbocation, right, or the positive charge. So I can put this carbon here, right? That carbon was already bonded to a methyl group. Let me put it there, CH3. I'm trying to break everything down so that you understand whatever that is going on. And this carbon was also bonded to this side, right? And now you are having a bridge. You are having a bridge. On this bridge, you had two methyl groups, so CH3, CH3, right? And this bridge was actually connected directly onto this particular carbon. So you see how it is. We've raised it. The bond was like this, but now it is from this carbon to this carbon. So this is where our positive charge will be. In case you are confused, it is even forming three bonds. So obviously the one that is bearing the carbocation. So from there, you know what we can do. I can just redraw it this way without showing the carbon. And now I'm going to have exactly. So nowadays I can just put carbon here, put something here, and then the methyl group was here, and now, right, as you can see, and I'm having my methyl groups CH3, CH3. This is where the positive charges. Okay, this is where the positive charges. So now ask yourself, what else can we do next? So the next thing we can do is number it, because if you don't number it, you are going to find it very difficult. Now if I should number this thing right now, I'm going to have a 6-membered ring and also a bridge like what you are seeing here. Just I'm going to rearrange it, because this is a rearranged species. It's a varying species, an intermediate. So I can have my carbon 1, I can have my carbon 2, I can have my carbon 3, I can have my carbon 4, I can have my carbon 5, and I can have my carbon 6. So you see how I named it, how I numbered it, right? So now I'm going to have a bridge between carbon 3 and carbon 6, right? There is the bridge. So now I can just draw my cyclohexane like what you are seeing here. I can redraw it this way. can we draw it as cyclohexane, right? And now I'm having my bridge. So this is the bridge that I was talking about between carbon 3 and carbon 6. So meaning I can have my carbon 1 here, carbon 2, carbon 3. So carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6, as you can see. And there is a bridge here. So on carbon 1, I was having a methyl group, 2 methyl groups there. So a methyl group here and a methyl group, CH3, CH3. And it was on carbon 2 that I was having this particular carbocation. So this is my carbocation will be now carbocation. As you can see, I've just numbered it, so don't forget about it. Now, ask yourself, we are also having a methyl group on carbon 2. So I'm having my CH3 here. So now you see we are using a dehydrating agent, right? So now let me try and redraw it again. Because we are using a dehydrating agent, I have this, I have this, I have this, and now let's see how interesting this molecule will be in the presence of my dehydrating agent. So here I'm going to have my CH3, right? CH3 here. I'm also going to have my CH3 also here. And because I'm using a dehydrating agent, I'm supposed to create a double bond because the bridge should be there. Yes, don't forget about it. The bridge should be there. And now, within the positive charge here, I'm having my CH3. So CH3, I can just write CH2 and just bring one of the hydrogen here because I'm having a lot of HSO4 minus. This HSO4 minus is a positive charge here, don't forget, on this carbon. That's the carbon 2. This HSO4 is going to take this hydrogen. When it takes the hydrogen, the bonding electrons will move onto this side to form your double bond. So that's how come we are having our molecule, right? And I'm going to have final product, right, to be something like this. And then we are going to have our double bond, so our carbon with the double bond here, and then we are going to have our methyl group. So you see, so that will give us the main compound that we are expecting. So now we have moved from this particular compound. In the presence of concentrated A2SO4, we have moved from this compound, which is an alcohol, all the way to this alkene. Alright, so that brings us to the end of the reactions under the Wagner reagents. Now, Wagner rearrangement, and we are supposed to move to the pinnacle rearrangement reactions. So before then, we are supposed to solve a lot of questions, right? So I'm going to continue posting a lot of questions and also the kind of product that we'll be expecting. So we will become very, very, very good at predicting the kind of products that we should be expecting at the end of the day. Alright.